Good day to you learners. Hope you are doing fine. In today's lesson in mathematics, we are going to discuss surds. At the end of this lesson, you should be able to solve questions under surds. So surds deals with rational and irrational numbers. So what are they? What are rational and irrational numbers? Let's use this to help us solve or understand rational numbers. So, taking only the positive square roots, such as root 9 and root 25, we can see that with this positive square roots, with the root 9, you have to get 3, and root 25, you have to get 5. So this gives us the exact value for the expression. But let's look at this. So these are called rational numbers. So let's look at this. Root 2, root 3. I'm just using two examples to illustrate this. So with root 2, we'll get something like 1.441. 42136. Yeah, so you can see that this is not giving us the exact value, but these values are in what? Decimals. So this is what we are saying. So we are saying that these are called rational numbers. Rational numbers, and these are called what? Irrational numbers. So rational numbers gives us the exact value, then irrational numbers does not give us the right value, or the exact value. So let's look at how to reduce numbers or perfect squares to the lowest or to the basic form. Example, we just use root 9. Let's look at root 16, and root 16, what do you think we'll get? Root 16 is giving us 4. What of root 169? What do you think will be the answer? Very good, 13. Yes, okay, so basically when you know this, you'll be able to solve sets as we move on. So let's look at how to solve sets by breaking them down. So let's take an example, reducing root 27 to its basic form. Now, to be able to solve this, now look for the factors of 27, or look for numbers that when you multiply will give you 27. Bear in mind, these numbers, one should be an irrational number, and the other can be the first one should be a rational number or irrational number. Definitely, both of them should have rational and irrational numbers. Okay. So let's look at this. Root 27. I'm going to break it down by 9 and 3, right? 3, 9, 27, right? Okay, so 9 and 3 will give us 27. Now we have to break this 9 and 3 down. So we give them separate roots. So root 9 times root 3 is the same as square root of 9 times 3. So with this, root 9, from the first example, we saw that the answer is what? 3. But with root 3, we are not going to get the exact value. So we leave the root 3 like this. So the answer for root 27 in surds is 3 root 3. That's interesting, right? Okay, let's try different examples. Let's go for root 37. Square root of, 32. Square root of 32. So let's look for the number. So 32, you can say 16 and 2, right? 16 and 2. 16 and 2. 16 times 2 will give you 32. So 16 and 2 giving us 32. Let's give them separate roots. Okay, so we have separate roots for 16 and 2. Okay, so let's bring the 16 down. Let's reduce it. So root 16 from the example I gave earlier on, we said it's what? 4. Right? Good. So now with the root 2, we are not going to get the exact value. So we repeat root 2. And this is the answer in Surds. So square root 32, this will be the answer for root 2. So let's keep on trying more examples as we follow this video. You can pause this video to try your hands on different questions. Okay, let's look at the next one. Right here, root 8. Root 8. Root 8. So let's think of it. Let's see, 4 times 2, right? 4 times 2. Give them separate roots. That's the next step. Then, after that, square root of 4 gives us 2. Left with root 2. Very good. Very good. You've done well. Try this and let's see. Square root of 128. Next example, square root of 128. I'll give you time to try. Square root of 128. Square root of 128. Square root of 128. I'll give you 1 minute. Okay, so what did you get? Okay, let's solve it together. We have square root of 64 times 2, right? 64 times 2. Let's give you separate roots. 64 and 2. So square root of 64 will give us 8, then square root 2. So this will be our answer. This will be our answer, 8 root 2. Now, let's look at how to add and subtract steps. Addition and subtraction of steps. Addition and subtraction of steps. Okay, addition and subtraction of steps. So there's the rule. So rule 1, as we have m root k plus n root k giving us m plus n root k. Here's the first one. With the same example, m root k minus n root k give us m minus n root k. Okay. So that is that. So we are going to use this to solve questions involving addition and subtraction. Okay, so let's jump in straight to our first question. So question 1, we have 5 root 2 plus 3 root 2. So let's do the addition together. So assume this is our m, this is our n, and this is our root k. From the example, we said 5 plus 3, then square root 2. Right? Good. So we are to get 8 root 2. Good. Now try your hands on this one. Question 2. I'll give you a minute 4 root 3 plus root 3. Try your hands on this. Let's see. Okay, so what did you get? So let's solve it together. So here we'll have 4 plus 1. Why did I say 1? There's 1 here that we didn't write. So this side is 1. Then root 3, giving us 5 root 3. 5 root 3. Okay. Let's keep on trying. Let's look at question 3. We have 2 root 5 minus root 5. 2 root 5 minus root 5. Okay, so what will be our answer? So here we have 2 minus 1 root 5, giving us root 5. I should have written 1 root 5, but we don't write 1 root 5. It's just root 5. Okay, let's keep on trying more examples. Question 4, we have 2 root 5 minus 5 root 5. Okay, so let's try. So we'll have 2 minus 5 square root 5. Okay, so let's see. This will be negative 3 root 5. Negative 3 root 5. I hope you are getting the examples. Okay, since we've seen this, let's look at how to expand or reduce sets in the following questions involving addition and subtraction. Involving addition and subtraction. Okay, so let's see. So let's try this first example. Example 1. So example 1, we have root 50 plus root 32 minus root 162. So we have to simplify root 50 plus root 32 minus root 162. Root 162. Okay, so let's continue with the work. We are looking at how to solve such question. So you have to simplify root 50 plus root 32 minus root 162. So with root 50, as I was explaining, root 50 will be 2 times root 25, or 2 times 25, giving us 50. Then 32, 16 times 2, giving us 32. Then 2 times 81, giving us 162. So in this step, I gave it separate roots for us to be able to solve this. Let's move on. So with root 2, we can't do anything about it, but with root 25, that will be 5, right? So here we get 5 root 2 plus root of 16 is 4, so 4 root 2 minus root of 81 will be 9, right? Root of 81 will be 9, so 9 root 2. Okay, so 5 root 2 plus 4 root 2 minus 9 root 2. So let's see. So let's add 5 plus 4, giving us, okay, let's do it this way. 5 plus 4 minus 9 root 2. So 5 plus 4, 9 minus 9, giving us what? 0. So 0 times root 2 is what? 0. So the whole answer is 0. I hope this is clear. Now, let's take a different question. Let's solve it. Let's see how it tends to be. So let's look at example 2. Example 2. Square root 147 minus root 75 plus root 27. Okay. So question 2, root 147 minus root 75 plus root 27. Now let's break them down. So let's put them here. Root 147 will be 49 times 3. 49 times 3. Okay. Now let's move on to root 75. That will be 25 times 3. Then let's look at 27, giving us 9 times 3. 9 times 3. Okay. So this is the second step. Now let's break it down into separate roots. 49 root 3, root 25 root 3 plus root 9 times root 3. Okay, so let's break it down. Root 49 is giving us 7 times root 3. 7 root 3 minus root 25 giving us 5. So 5 root 3 plus root of 9 is giving us 3. So 3 root 3. So which one comes first? Addition first, right? Or subtraction first? Okay, we can subtract and add. Okay, so let's see. So here you can write it this way. 7 minus 5 plus 3 roots 3. So let's see. 7 minus 5 giving us 2. And 2 plus 3 giving us 5 root 3. So 5 root 3 is the answer to square root 147 minus square root 75 plus square root 27. Okay, so this is how to solve addition and subtraction of said questions. Now, let's look at the rules of sets. Rules of sets. Rules of sets. Now, the first rule, the first rule says square root a times square root a is equal to a. Square root a times square root a will give you a. How is this possible? Okay, so let's explain. Square root times square root. So you can write this expression as square root a squared, right? That's it, right? Okay. So which gives us now, in changing the square root, we'll have a raised to the power half times 2. So this half represents the square root times the 2. So this will be a 1 times 2, that will be 2 over 2, which is equal to 2 cancels itself, so that will be 1. So a raised to the power 1. Now any number raised to the power 1 or any alphabet raised to the power 1 is what? Same number. So the answer is what? A. Good. A. I hope this is clear. Now let's look at the second rule. Second rule says that a square root a squared is same as a. So I've explained it down up there. Another example. So with this, you can get a question like square root 3 squared, which would be equal to what? 3. So that's the interpretation of this one. Now let's look at the third rule. We have many rules. We have square root a times square root b giving us square root of a times b. So you can have a question or an example. So example, we have square root 2 times square root 3, which gives us square root 2 times 3, which is square root what? 6. Right? Okay, very good. Now let's move on to the next one. Square root a divided by square root b will be written as square root of a over b. Like this. So an example square root 6 over square root 2. Square root 6 over square root 2 will be represented as square root 6 over 2, which will be 2 goes there, 1, 2 goes there, 3. So that will be square root of what? 3. Good. It's good you are trying. Yeah, so basically these are some of the rules. Some of the rules to sets. There are more. Okay, let's move on. Let's look at the fifth rule. Fifth rule, we have a root b times root c giving us a root bc. So you group the square roots together, multiplying the a. So let's say example we have 2 root 3 times root of 5, right? Root of 5. So this will be 2, then 3 times 5. So that will be 2 root 15. Okay, let's look at the sixth rule. The sixth rule, we have a times root b. A times root b, that will be a root b. A root b. So let's give an example. Example, we have 2 times root 3 giving us 2 root 3. As simple as that. Now let's look at the seventh rule. The seventh rule giving us a root b times c root d. So we have to group them. So we have ac square root bd. AC square root bd. So let's look at it. Example, 2 root 3 times, let's say 4 root 2. So here we set 2 times 4 square root 3 times 2. Right? So our final answer will be 8 root 6. 8 root 6. So basically these are the rules. These are the rules in solving sets. So if you are able to get these rules, it will be very simple to solve. Okay, so with these rules that we've written from rule 1 to rule 7, now let's look at how to solve questions using these rules. Okay, let's look at how to solve questions using these rules. So I'm going to use one as an example. To how to solve said questions. So let's see. Okay. So I'm going to use this example. So simplify 2 plus 2 root 7. 2 plus 2 root 7 multiplying 5 minus root 7. So 2 plus 2 root 7 multiplying 5 minus root 7. 5 minus root 7. Okay, so let's expand. Let's expand. So I'm taking the left hand side to expand it. So 2 or to multiply this. So we have 2. I pick what's here, 5 minus root 7. Then plus, I was left with this 2 root 7. Multiply with this again, 5 minus root 7. So I'm just expanding, okay? So let's multiply. So 2, 5, have 10. Minus 2 times root 7 will give you 2 root 7 from the root plus, now let's multiply 5 times 2, that will be 10 root 7 minus, now this will be 2 root 7 times root 7, alright, so this will be 2 times 7. We said earlier that root 7 times root 7 will give you 7. We said root a times root a is equal to what? A. Good. So this is it. So here we are going to get 2 times 7. 2 times 7. Okay, so let's continue with our work. So 10. So we have negative 2 root 7 plus 10 root 7. So this will be minus 2 plus 10 root 7 and minus 2, 7, 14. So what are we to get? So here we are owing 2. Okay, let me put this here, not to confuse some of you. I expanded this to be clear. Oh. Yeah, so 2, you are owing 2 cedis and you pay 10 cedis. You are owing what? 8 cedis. So this will be 10. Yeah, sorry, you are owing 2 cedis and you pay 10 cedis. So that will be 8 cedis, positive 8, right? So plus 8 root 7 minus 14. 8 root 7 minus 14. Now, let's subtract. Now we are left with these whole numbers here, 10 and 14. So this gives us what? Take 14 from 10, that will be negative. So our answer will be 8 root 7 minus 4. 8 root 7 minus 4. So this is our answer to the question. I hope it's very easy, right? Yes, very simple. Okay, now let's try another question. Just this one last one. Let's take a look at this. Root 3 minus 1. Sorry, 2 minus root 3. Okay, so let's go. So let's expand, pick one here, root 3, expand, pick everything, minus root 3, then minus 1, pick this again, 2 root 3, 2 minus root 3. So this gives us 2 root 3, 2 root 3 minus, now root 3 times root 3, you get 3, then minus 2, 2 and 2. Now, negative gives us what? Positive. Plus. So 1 times root 3, we have root 3. Okay, so now we can group the root 3, then we group the 3 and 2, right? Okay, so negative 3 minus 2, that gives us what? Minus 5, right? Now, 2 root 3 plus root 3, that gives us 3 root 3 minus 5. So this will be our answer. This will be our answer. 3 root 3 minus 5. Some may choose to write negative 5 plus 3 root 3. Still the same. Still the same. Okay, so I hope this will help you solve questions involving surds. Right? Okay, I hope everything is clear. Now, let's look at a conjugate surd. A conjugate surd. So, given the surd root A plus root B, its conjugate surd will be root A minus root B. So given the surd root A plus root B, its conjugate will be root A minus root B. So all what we are saying is, if the first question was positive, the conjugate will be what? Negative. If the first question involves negative, the conjugate will be what? Positive. Now let's solve a question and this. So this is a question, example 1 under this. Multiply the following by a bracket which will make the product rational. So 2 minus root 3, this is the question. So you have to multiply this question by a bracket which will make the product rational. So we are going to multiply by its conjugate. So this will be 2 plus root 3. 2 plus root 3. 2 plus root 3. Okay, so let's expand. And this is a perfect square. This is a perfect square. Or what we mean is, if you have A plus B, multiplying A minus B, your answer will be A squared minus B squared, right? Okay. So let's use this. So this will be 2 squared minus root 3 squared. So this gives us 4 minus this gives us 3. So our answer is what? 1. So this is our answer. Okay, so please try this question 2. Try this on your own. Let's see, root 7 plus 2. You are to multiply by a bracket which will make the product rational. You have 2 minutes. Your time starts now. Okay, so what did you get? The answer is what? 3. So this will be root 7 squared plus, minus 2 squared. So this gives us 7 minus 4. Our answer gives us what? 3. Very simple. Very, very simple. Okay, so this is the conjugate of what? Surds. Conjugate of surds. So positive of the question, its conjugate is what? Negative. Thank you very much for understanding. Okay, now our last topic under surds will be rationalizing of surds and equality of surds. Rationalizing of surds and equality of sets. So let's look at rationalizing of sets, rationalization of sets. So we are going to rationalize the denominator, and this is the process of making the denominator of fractional sets whole or rational numbers. Okay, so let's try this example. We have 1 over root 2. Now we have to rationalize it. So this would be 1 over 2 times the denominator again, root 2 over root 2, which gives us 1 times root 2, then root 2 times root 2, giving us what? 2. So this is it. Try your hands on this. 2 over 3. 2 over root 3, sorry. 2 over root 3. Let's rationalize it. So multiply both sides by 3, root 3. So this gives us 2 root 3 all over what? 3. So you can split it as 2 over 3 root 3. You can end here. Some may try to do this, still the same thing. Okay? Yeah, so now let's take a look at this question. Let's look at how to rationalize this question vividly. So, question 1, we have 1 over 4 minus root 5. 1 over 4 minus root 5. So with this one, we have the denominator to be negative. So in rationalizing it, we use the conjugate. So let's go with 1 over 4 minus root 5. Multiply it by 4 plus root 5 all over 4 plus root 5. Are you getting the whole show? Yeah, so 1 times this gives us 4 plus root 5 all over 4 squared minus root 5 squared. Our final answer will be 4 plus root 5 all over 4 squared, 16 minus 5. So now let's write our answer. So this will be 4 plus root 5 all over what? 11. All over 11. 4 plus root 5 all over 11. So we can split it as 4 over 11 plus root 5 over 11. Leave the answer like this. Okay, so I hope with these examples you'll be able to solve questions under sets. You'll be able to solve questions under sets. We have complex ones that takes time, it takes time. Okay, let us try this question. Let us try this question. This question, 5 over 3 plus root 2 minus 2 all over 3 minus root 2. Now this is a complex question. Complex one. Yes, it's very complex. Very, very complex. So this is what we are going to do. We are going to multiply both sides by the conjugate, okay? So here we'll have 5 over 3 plus root 2 times 3 minus root 2 all over 3 minus root 2. Are you getting it? So this is for the first side. Now let's move to the second side. 2 over 3 minus root 2 times 3 plus root 2 all over 3 plus root 2. So we are multiplying both sides by the conjugate. Okay? Okay, so this gives us 5 into brackets. Okay, let me expand everything. This gives us, okay, let me write it this way, 5, 3 minus root 2, all over. This gives us 3 squared minus root 2 squared. Then minus, let's move to this side, we get 2 into bracket 3 plus root 2 all over 3 squared minus root 2 squared. Okay? Okay. So let's move on. Okay. So this and this are the same, so we pick the same thing. So here we have 15 minus 5 root 2. Sorry, 5 root 2 minus then 2, 3, 6 minus, now negative affects this, so minus 2 root 2 all over 3 squared minus root 2 squared. I hope it's clear. Okay, so let's do the subtraction. Okay, so 6 from 15, we are to get 9. Now, negative 5 root 2 minus 2 root 7. So that will be negative 5 root 2 plus 2 root 7. Are we there? I hope it's clear. Sorry, negative 5 minus 2, so negative 5 minus, so that will be minus 7, right? Root 2 all over 3 squared 9 minus 2. Our answer will be 9 minus root 7 root 2 all over. This gives us what? 7. So now the question says simplify 5 over 3 plus root 2 minus 2 over 3 minus 2, leaving your answer in the form a plus b root n. So this was the condition, a plus b root n. So that was the condition where a, b, and n are constants. Okay, so let's represent it in this form. So let's split this. We have 9 over 7 minus 7 root 2 over 7. Okay, so now we can also split this as 7 over 7 root 2 like this. 7 over 7 root 2 to look like this one. Alright, to look like this one. So 7 over 7 gives us what? 1, right? So still expand, you get 9 over 7 minus root 2. So now our a becomes 9 over 7. Our b becomes, there's 1, so minus 1, and our n becomes 2. Our n becomes 2. So the question says simplify 5 over 3 plus root 2 minus 2 over 3 minus root 2, leaving your answer in the form a plus b root n, where a, b, and n are constant. So we will have this as our final answer. So our a becomes 9 over 7. Our b is negative 1. and our n in the square root becomes 2. Okay, so this is generally one question that we can also focus on. Okay, let's take another complex question. Let's take another complex question here. We have root 5 into brackets root 5 plus 3/2 root 5. Okay, yeah, so we were discussing on how to solve this question. So solve square root 3x plus 4 minus square root x plus 5 is equal to 1. So what you do is, let me bring this. What you do is, you move this to the right hand side to become positive. So you have square root 3x plus 4, then 1 plus x, square root x plus 5. Now, after doing this step, you square both sides. So this is it, that's the next step. I squared both sides. Now, when you square both sides, for this is the explanation of the squaring of the other side. So I'm going to get 1 plus x plus 5 plus 2 root x plus 5. Okay, so you can do the squaring somewhere. I did mine on the left side. Okay, so now let's group the x together. So we have 3x minus x. That will be equal to, okay, let me group this. Plus 4 minus 5 minus 1 is equal to 2 root x plus 5. Okay, all right, so I'm just doing the grouping here. Okay, so that will be 2x. 4 minus 5, that will be negative 1 minus 1, that will be minus 2. Minus 2 is equal to 2 root x plus 5. Okay, now the next thing we have to do is to still cancel the square root over there. So we have to square both sides. Square both sides. Let's square both sides. So let's square. So I can do the squaring here. That will be 2x minus 2 minus 2, 2x minus 2. So that will be 4x squared minus 4x minus 4x minus 4. So with the squaring, we have to get 4x squared minus 8x minus 4. For this side, it's equal to, now let's square this. Let me square that on the left hand side of the board. Let me square it here. Okay, so this square, that will be 2 root x plus 5 all squared. That gives us 4 into bracket x plus 5. So this square for 2 and this cancels together with this. So we have 4x squared minus 8x minus 4 is equal to 4x plus 20. So 4, 5, 20, right? Okay, good. So now let's group them together. We have 4x squared minus 8x minus 4x minus 4 minus 20 is equal to 0. So now we have another equation. So that would be 4x squared minus 12x minus 24 is equal to 0. So this you can reduce it by 4. So divide by 4 to reduce the number. So when you divide this by 4, you get x squared minus this by 4, you get 3x. Now divide this by 4, that will be 6. It's equal to 0. So I'm going to use this. in working it. So this squared is going to give us, the answer for this is going to give us x minus 4, x plus 1 is equal to 0. So x minus 4 is equal to 0, x is equal to plus 4, or x is equal to positive 4, x is equal to positive 4, or x plus 1 is equal to 0, x is equal to negative 1. Okay, so x is equal to 4 is a solution since it satisfies the original equation. But x is equal to minus 1 is not a solution since it does not satisfy the original equation. So the answer for x here is 4. This brings us to the end of Surds. I hope this lesson and this well explained lesson will help you to solve more questions on Surds. I'll see you in the next video. Bye bye.